Hi, I'm Scott McLean from transmusicmastery.com, and in this video I'm going to program the high roller bass patch on Sylenth1, and this is the patch that Adam Sabo originally created on Zebra 2. And so now what I'm going to do is program that on Sylenth1. So let me move this out of the way for a moment. And if I switch over here to the Sylenth1 track, I have Sylenth1 already set up with the init preset sound. Okay, and I'm going to follow the same technique by disabling each of these modules. This is the same technique I've been using to match the sounds. So now we have oscillator 1. It's a single oscillator. It's a saw wave. And in this case, it is an inverted polarity, so the ramp is up. So for Sylenth1, we can use non-inverted waveform that it has because it already has, by default, its saw waveform is ramping up. And it's using a single voice. It does use oscillator effects, which we do not have that capability within Sylenth1. We don't have the ability to put individual effects on the oscillators. The effects that we do have available are here in the center, so what we will have to do is try to match the sound as best we can. Volume is at 200 and width is at 50. So let's go ahead and play this sound. And right off the bat, we can hear that the arpeggiator sequencer is enabled. So what I'm going to do is temporarily disable that so that we can get the timbre of the sound correct, or the tonality. So let's listen to this. Alright, so first things first, we've got the global tune in Zebra at -12, so we need to tune the Sylenth1 oscillator down 1 octave. Okay, and now that we've matched the sustain level, let's make sure that the maximum level that the patch reaches, actually let me reset these fader values to 0. So notice on Zebra 2, if I play it, it reaches that maximum level and then decays down to the sustain level. So let's go ahead and set that up for the decay part of the amplifier envelope in Sylenth1. And in fact, I'm going to have to increase the level here of mix A. It's not quite as loud as Zebra 2, and I've got the volume at maximum, both from the oscillator and the mix A and the main volume. Okay, so let's go ahead and continue with bringing in oscillator 2. That's going to be tuned up 1 octave. It's also a single wave, and it's a saw wave. So I will leave oscillator A2 at octave 0 because the global tuning on Zebra 2 is at -12. So that would correspond to being 1 octave higher than oscillator A1, having octave 0 versus octave -1. And I need to increase the voice to 1, voices, set that to 1, and set the wave type to saw wave. And this oscillator is detuned away from oscillator 1, so we can achieve that in Sylenth1 by adjusting this fine tune control here on oscillator A2 and moving it in the positive direction. Okay, they sound very similar at this point. Now let's enable oscillator 3, and that is a single voice oscillator sawtooth waveform. And this one is tuned at +2 octaves, or 24 semitones, and detuned in the negative direction. So let's go ahead and do that with Sylenth1. I'm going to use part B, set oscillator B1 voices to 1, saw wave, and octave, set that to +1. So now oscillator B1 is at +2 octaves from A1, because A1's at -1 and oscillator B1 is at +1. So now the other thing I'm going to do is copy the amplifier envelope, paste it onto part B's amplifier envelope, and finally let's go ahead and play that. And then we just need to detune it in the negative direction. Okay, and you can hear that the Zebra 2 sounds brighter, and that's due to this brilliance effect here on oscillator 1, 2. So oscillator 1 and 2 have the brilliance effect, and then all three have that fundamental. So right now we have the basic timbre very close except for that brilliance character. ADSR envelope settings are about the same. So before I add this filter, what I want to do is set up the step sequencer. So let's go ahead and add that back. In fact, let me decrease the overall volume level. And now for Sylenth1, let's go ahead and set up its step sequencer. So the way we do this is we use this arpeggiator, enable that, and it's got various modes, up, down, up, down. It's similar to how the step sequencer works with in the arpeggiator with Zebra 2, but this one mode here, step, is the one we want. Okay, that allows us to configure the specific transpose notes similarly to how we did in Zebra 2. So what I'm talking about is if I select ARP sequence down here, we've set -12, 0, 12, 0, -12, 0. So these alternating octaves. So one octave down, then at 0, then +1 octave, 0, -1 octave, and so forth. So now we can set that up in the Sylenth1 arpeggiator the same way. And we want to start at 1 octave down, 0, and then 1 octave up, and then repeat. So transpose, I'm going to set that to -12, then 0, then up +12, then 0, then -12, 0, +12, 0, and then set the page to 2. That gives us the next 8 steps. -12, 0, +12, 0, -12, and then these last 3 are, let's see, -12, -2, 10, and 3. So -12, -2, 10, and 3. Okay, so now we should have the same note pattern played from the Sylenth1 arpeggiator that is being played by the Zebra 2 arpeggiator. And I'll point out some differences in a moment. Okay, timing is 1, so we need to increase the rate. So that would be time here. We want to set that to 16th. Okay, so note values are different. The length, the duration of the notes are different actually. So if we look at the Zebra 2 arpeggiator, this gate value controls how long those notes are relative to the length that's specified above here, the 16th note. So it turns out we don't actually have that capability to vary the individual notes in the pattern. The lengths of those notes, we cannot do that in Sylenth1. They all have to be the same length. Okay, now there is a feature here called hold, which will hold the duration of that step for the entire time until the next one plays. So that helps us get closer. So I'm going to use that feature, and I'm going to set it on the +1 octave step. So that's step 3, and then this step. So each of the +12 steps, those are going to get that hold, and that will extend the length of that particular step. So let me go back to page 1, set the hold on this step, and then that one. So now when I play it, it sounds like this. You can hear that that note on the +12 is being held a little longer than the other steps. Now we can vary the gate length. The gate here, that will actually adjust all of the lengths. 50% indicates that it's 50% between the step length. So what I can do now is just increase that. And what would be cool is if we could modulate this gate parameter, but we can't actually. So if we come down here to the modulator section and we look at what are the possible targets of modulation, there is nothing in here that represents this particular control. All right, but let's see if we could automate it using a clip envelope. And actually, I don't know if it's possible. I haven't looked at this. I just kind of had that idea just now. So let's see. It does show up here as being automatable as a target. So what we could do then is if this is a 16th note pattern, then we could basically come in here and draw a similar alternating or varying gate length that we have set up in Zebra 2. And this should give us what we're looking for. Let's see. Okay, now I don't know if those actually correspond directly to these same note lengths here, or step lengths. This is a 2, 3, 4, so I'm not sure how that equates to the total length of the step, but it's mimicking the concept. So let's go ahead, I'll leave it like that for now, and let's compare those two. I think we need to bring the release up some on the notes, on the ADSR envelope, so let's try that. Okay, I'm going to leave it like that for now, and then we'll come back if necessary and tweak that envelope. You know, that's something to look out for when you're using this different features of a synthesizer. You may not be able to replicate this sound exactly, and this is a good example of the fact that we cannot control the individual note step lengths within Sylenth1 the same way that we can within Zebra 2. Alright, so now we can come back to this and look at adding this cross modulation filter. So let me add that. We can hear what kind of effect this is having now. Alright, so now the idea is to mimic that sound using a filter on Sylenth1. So I'm going to route all 3 oscillators into filter A and make sure that I disconnect oscillator B's output from filter B. So now the only part that's being heard is part A plus the output from oscillator B that's flowing into the filter. I'm going to set it to low pass, 24 dB slope. And one thing that we want to look at is there's some modulation occurring on this cutoff frequency from ENV2 as well as the ARP modulation. Okay, if we go back over here to the arpeggiator, we see that we have this ARP mod, and we'll look at that in a moment, how we might achieve that with Sylenth1 if it's even possible. So let's go ahead and deal with envelope 2 first. And so before I look at this, I'm going to disable ARP mod basically by setting its amount to 0. So now the only thing modulating the cutoff frequency is ENV2. Alright, so let me bring up the cutoff frequency a bit. And I'll try to mimic that sound with Sylenth1. Okay, it's got a different dynamic element to it, and the primary reason for that is, if I bring up Zebra 2 real quick, notice envelope 2 uses the concave envelope curve. It's a variable slope curve, and it's concave. Listen to what happens as I bring this back to linear, and Sylenth1 envelopes are linear. Okay, so let's look at that. So now what I'm going to do is try to match it with that linear slope. I think that one of these oscillators is too loud. It's this +1 here. Hold on. Okay, so one thing is that with this linear modulation envelope, we're not going to be able to achieve the character of this high roller bass as it is in the Zebra 2 patch, okay, that Adam created, because he's got it way over here. In fact, let me just reset that. Okay, it's over here at -93. So if we listen to it now, it's very plucky sounding. Okay, it's got a snap to it. but we can come close. We can try to get it closer. I'm going to try bringing the modulation amount down on Sylenth1. I think that might be as close as I can get this particular envelope setting. So, alright, so next, let's look at the next element, which would be the effects. So with the EQ, I'm going to go ahead and enable both EQs and then try to use the Sylenth1 EQ to match what we hear in Zebra 2. In fact, let me make sure that that cutoff frequency is set back to where it was. Then disable these. Okay, so now what I'm going to do is try to match the EQ sound from Zebra 2. Okay, that's probably as good as I can get it with this EQ. Now, let's try using, let me move these guys out of the way real quick. Let's try using the EQ8 from Live, which will help us match the original programming of the EQ in Zebra 2. So it looks like we've got a general lift around 550, 3 kilohertz, and then high end above 10K. So let's put that in. So 350. Okay, you can tell there are differences in the tonality, and that's to be expected because we're dealing with two different synthesizers. Okay, so now let's go ahead and enable delay 1. Let's add the delay. And we can see that we've got 1/4 and 1/8 dot, so we need to set those timings, and this ratio 1 is at 50, so this is 1/8 and 1/8 dot. So 1/8, 1/8 dot. Disable ping pong. And then I'm kind of looking at how they decay here, the meter levels as they fade. They're both fading about the same rate, so that indicates that chances are that these delays are going to sound about the same. So let me go switch back and forth. Okay, so timing wise they seem to last the same length of time. But tonality wise the sounds are slightly different, so let's listen. try increasing the drive a bit, see if that has any effect on this tonality, see what kind of effect that has. Okay, next we need to add the reverb, so let's go ahead and do that. I'm going to enable that. You can see dry is at 78, wet is 22.5, and feedback's at 43, range, so it's kind of a, let's hear how that reverb sounds actually. Let's bring dry all the way down to 0. Just listen to the reverb effect. And I'm going to enable reverb on Sylenth1 and increase its dry wet to 100%. So all we're hearing is the reverb. So we need to shorten this room size. And I increased the dampening to warm it up some. So let's go ahead and try that out. Let me bring it back to right about here. Okay, so now let's go ahead and look at how we might accomplish this ARP modulation that we have in Zebra 2 using Sylenth1. So the question is, what on the step sequencer can we use to help modulate the sound? Okay, if we look at the source, we've got velocity. Here we have step velocity. Okay, so we could use step velocity to modulate the filter cutoff frequency, and that's what I'm going to try to do now. So the idea being that over here on high roller we've got this ARP mod further modulating cutoff frequency in addition to envelope 2. So here we have values of 40, 60, 60, and 60. So it's about 40%, because I think that the maximum level is 100, so if we bring this back to 40. So the first note gets some, and then the next 3 notes get more modulation. So let's go ahead and achieve that using this velocity. Let's see what our maximum velocity is, 127. Let's try bringing the velocity down to 80 on the first note, and then leaving it at 100 on the subsequent notes. So, and that's in groups of 4. So on the 5th step here, I'm going to bring that down to 80, leave these at 100, set this one to 80, leave these next 3 at 100, and then set this next one to 80, and leave the next 3 at 100. So now the step velocity is going to modulate the cutoff frequency by this amount. So let's see what kind of effect this has. As I increase, I'll start with no step velocity modulation of cutoff A, and then I'll gradually increase it. I'm noticing that it sounds closer to the actual Zebra 2 patch if I apply negative modulation here. So I'm slightly negative at 0.86, negative 0.86. So let's see if I bring this down some more, if it gets closer. I think that's as close as we can get with this particular synth. And that's it for this video. I'll see you in the next video.